Understanding Mhor Circle Part 2. Okay, let's have the part 2 of this series. Alright, so again, welcome back to Gillesania Engineering Videos, your daily supply of solutions to engineering problems. If you like what you see, please subscribe and don't forget to hit the bell icon so that you'll be notified every time we upload new videos. Okay, so in part 1, we discussed the state of plane stress, no? And then we discussed also a passport exam. So, sinadya ko yung para ma-relate nyo yung paano to do it manually, and we check it using the Mohr Circle. Kasi kung diretsuhin natin ang Mohr Circle, most students baka magduda. Oh, tama ba yung sagot na yan? At least kung meron kang isang solution na which is a very straightforward, and then knowing na pareho lang yung sagot nila, then that would, kumbaga sa ano pa titibay yung paniniwala mo, no? Sa solution. Alright. Okay, let's have an example here. Though this is not a board exam, pero the principle is very, very applicable talaga. Now, you might ask me, okay, ito yung problem. I think you have seen this in my last part 1. No? Hindi ko nakita to last in part 1. In the last part of the video. Now you might ask me, sir, how could it happen na mayroong stress in both axes? The one that we had in part 1 is only uniaxial stress. Ano yung biaxial? Meron ba yun? No? Kung alam nyo yung triaxial sa soil, meron talaga. No? Okay, tingnan natin. So here we have the pressure tank shown has a diameter of 600 mm and a thickness of 6 mm. The pressure of gas in the tank is 800 kilopascals. Alright, ang first question, the maximum tensile stress in the tank wall. Okay, tensile stress. And the maximum shearing stress in the surface of the tank. Shearing stress in the surface of the tank. Okay, I know you're very familiar with the formulas here, no? The tangential and the longitudinal stresses. Well, among the two, mas malaki yung tangential kaysa sa longitudinal stress. So maybe you can easily answer part 1 here. Ano nga yung formula? Thin-walled pressure vessel, cylindrical pressure vessel. Di ba? PD over 2T. P is the internal pressure, D is the diameter, and thickness is T. By the way, maraming nagtatanong sa akin, sir, ano bang gagamitin namin in the formula PD over 2T? Ano ba yung D? Internal or external? Actually, I will answer you this straightforward. This topic is thin-walled. The formula PD over 2T cannot be used if the thickness is malaki. Gaano kalaki? Is 1 mm thick or thin? I will ask you. Yung 1 mm thick ba yun or thin? Actually, it depends. 1 mm is thin if your diameter is, let's say, 3 meters. Correct? But 1 mm is thick if the diameter is, say, 4 mm. Did you get my point? So, yung thickness is relative to the diameter. But, okay, halimbawa, if your wall is 1 meter, if your diameter is 1 meter and the wall thickness is, let's say, 10 centimeters, the PD over 2T cannot be applied. That is considered as thick-walled cylinder. So, kung thin-walled cylinder, it should not matter if you will use the inner or the outer. But, well, of course, by principle, it should be the inside diameter. But it should not matter na malaki yung diferensya pag ginamit mo yung outer or the average for that case. It should not. Because if it will matter big, then that is not a thin-walled pressure vessel anymore. That is a thick-walled. That's my answer to that. Okay. Sige. So let's start. So the diameter is 600 mm. So let's use that one. And then the thickness is 6 mm. All right. Then the internal pressure is 800 kilopascals. 800 kilopascals. Okay, let's do first part 1. This is very easy. That's PD over 2T. By the way, in the board exam, pag sinabi mong PD over 2T, ginamit mo yung outer diameter and then walang lumabas doon sa choice, then try to use the inner diameter. No? Well, I'm just explaining to you the basic because kung malaki yung diferensya ng sagot, then it should not be a thin-walled pressure vessel anymore. But the examiner, I noticed she's using, if he emphasizes the outer and inner diameters, then use the inner diameter. I hope you get my point. Okay, so tangential, that is your tensile stress. The maximum kasi, dalawa kasi yung tangential tsaka longitudinal, no? So, PD over 2T yung maximum. PD over 2T. Let's convert the pressure in megapascal para maging consistent tayo. Na? By the way, in this formula, bantayan nyo lang na yung D tsaka T natin parehas ng unit. So, kung ano yung unit ng P mo dito, yun na rin yung unit for your sigma. Alright? Kasi baka cancel yung D tsaka T. So, taking P in megapascal, so 0.8. Now, times 600 yung D over 2T. So, that will give you 40 megapascals. Okay? So, that is your answer in part 1. Maximum. Now, the longitudinal naman is PD over 40. And obviously, that will be 1/2 of that. 1/2 of that. So that should be 20. By the way, sa review namin, in-explain ko pa yan. No? Dinederive pa namin yan sa review. Sa online man, we will derive that. We will discuss all those. No? Dito, we don't have that luxury of time. Okay. Sir, binibiting kami. Parang in-invite nyo kami, sir, na mag-review. And of course, free naman to. So, hindi naman siguro masama kung anuhin natin. Parang siniba. Parang trial version. This is a trial version of our online review. Okay. Ano ba yung tangential? Ano ba yung longitude? Saan ba yan? No? Many cannot identify which part of that. Okay. Cannot picture out saan yung longitudinal, saan yung tangential. Aminin nyo, maraming hindi marunong. Okay. I'll explain that to you. No? Let's trace the circumference and the length. Let's have that one. Okay. If you have an element here, a small strip of the wall, all right, the tangential stress is the stress along the circumference. That's why another term for that is circumferential stress. The stress pulling this strip along the circumference, that is the tangential. And the stress pulling this strip along the length, along the axis of that cylinder is the longitudinal. Ganon yan, Okay, baka hindi nyo pa alam yan. Okay, tangential longitudinal. All right, and this is a classic example of stress in both directions. No? Kaya kung i-expand natin yung element na yan, hilain ko, panoorin nyo hilain ko yan. Yan. Okay. So you have your element here. So this is just the XY plane, X and the Y. So this is just the in-plane transformation. I'll explain that to you kasi meron ding out of plane. Kasi tatlo man yung plane natin, XYZ. Pero I'm just taking the XY. Because the question in part 2 here is just the maximum shearing stress at the surface of the top. And that will be on the XY plane only. Okay. Along X is your sigma L, which is 20. And along Y is your sigma T, which is, your sigma T, which is your 40. Klaro na? Okay, sigma longitudinal, sigma tangential. Okay, the question here is the maximum shearing stress at the surface of the top. So let's plot the Mhor circle. Walang tao, no? Okay, I hope napanood nyo yung part 1. I hope you watch the part 1 of this video. Okay? So I will not draw na lang dito the tau, no, the shearing stress kasi wala namang shearing stress tayo. Okay? So, we need 2 points. Okay, ito yung ating plot, sigma and tau. Alright, the 2 points ay, okay, una dito, the principal natin ito walang tao, no? So, 20 yung sigma at ang x natin, we will locate x and y here. Ang x natin have coordinate 20, 0. 0 ang shearing stress, 20 ang normal stress, positive 20. Ang point y naman is 40, 0. 40 ang normal stress, 0 ang shearing stress. Yes, yeah? Okay? So, we will plot x and y. So, this will be your x, 20 ito. So, this is your x, 20, 0. And your y is 40, 0. Somewhere here. 40, 0. So that is your y. Okay. So this is your Mohr circle. Ayan. Obviously, the diameter of the circle is 20. The center is here. Yung center niyan, obviously, ay nasa gitna. Di ba? Talagang nasa gitna yan. No? Average of 20 and 40 is 30. Yung kanyang center. So, the maximum in plane shearing stress is ito. And that is equal to the radius of the circle. And that is, the radius of this is 10 MPa. Yun. That's the maximum. 30 minus 20. 10 megapascal and your tau max XY. Ayos ba? So the answer here is 10. Now, I've been saying in plane. Ano ba yung in plane, sir? Bakit? Kasi I mentioned kanina, because this is just the XY plane. Kasi merong Z-axis. Kasi solid yung wall. Huh? I will show you the axis. Alright, ito yun. Itong blue na plane dito, ito yung pinag-uusapan natin. Ito yung X-axis, ito yung Y-axis. Yung blue plane na yan, ito yan. There is the Z-axis also. No? Okay, perpendicular to that strip. Z-axis. Itong plane na ito, this is the XZ plane. Ito namang orange na plane dito is the YZ plane. Okay. You can also plot that in the same tau sigma plane here. No? Okay. Your sigma Z is wala. Your sigma Z is wala. Wala namang stress pulling this wall normal to the wall. Walang stress dito. Merong stress X and Y only. Pero walang stress perpendicular to that. Kaya yung Z natin, location ng Z natin, ito. Yan yung Z natin. So in other words, the plot of the Mohr circle for the XZ plane is ito. Ito yung Mohr circle ng XZ plane. I hope. Okay, kung nalito kayo, sige lang. Never mind. No? Hindi pa naman to lumalabas sa board. Pero sige lang, i-google nyo lang din para ma-reinforce yung ano nyo. Ha? Yung Mohr circle naman for the YZ plane is ZY, ito malaki. That's the Mohr circle for the YZ plane. So it depends on the plane that you're considering. The plane that we consider here is only the XY plane. Kasi ang sinabi dito, surface ng tank lang. Surface ng tank. Ha? Kaya ang maximum shearing stress at the surface is R. But the maximum shearing stress in the wall in any direction is actually ito. Kasi itong malaking circle, ito ang pinakamalaki. Na? Ito yung maximum shearing stress. In fact, ito yung formula nga eh. The absolute shearing stress maximum is the biggest of this one, circle here. Ito yung XY. Ito yung half of sigma X. Ito yung radius ng maliit. Ito naman yung half of sigma Y is the radius of the big. Ito yung malaki dito. Sigma Y kasi sigma Y is 40. Na? Sigma Y over 2 ang malaki. Na? Anyway, that I just added that just to add more topic. But anyway, siguro next time na lang, no? Pag-usapan natin further. Okay. By the way, the answer, kung ang tanungin ka about the maximum shearing stress in the material, the answer should be 20. Kasi it will happen on the XZ plane. XZ plane siya mangyayari na nasa XZ plane siya. Okay? Now, tanong ngayon. Sir, ano yung gamit nung may plane kanina? Di ba yung may angle? So, paano natin yung may angle na plane AA kanina? Okay, tingnan nyo to ha. Tingnan nyo to. Now, what if this tank is made by welding steel plates at an angle? Look at that. Wineld natin siya along that. Okay, ito yung weld. No? The angle of the weld to the horizontal is, let's say, theta, 40 degrees. Now, you want to know what are the stresses normal and parallel to the weld for you to design the weld. Ayun. Dito na papasok yung Mohr circle talaga. No? You cannot use anymore the formula kanina na sigma x cosine squared theta. Sigma x cosine sine. Hindi na. Okay, so let's do that. Kunin natin yung stress along that plane. So here it is. Let's go back to this. 40, 20. So that is making an angle of 40 degrees from the horizontal. Ito yung horizontal natin ha. Pag ganun siya. 40 degrees. So let's call this plane 40 degrees. Let's call that AA. So solve natin yung stresses along that plane. So let's plot this plane on the Mohr circle. Again, the x is this one. The x plane is ito. That y plane is that one. How about A plane? A plane makes an angle of 40 degrees counterclockwise from x. Counterclockwise from x. Alright? So ang gagawin mo, from x here, you move counterclockwise twice of that angle, 80 degrees. So, okay, panoorin nyo ha. Okay, panoorin nyo. Isa, dalawa, tatlo. Look. Ayan, and then 80 degrees. Then, that is not your A. Your A is there. I will repeat kasi sayang yung pagod ko dito paggawa ng animation. No? Alright, bang! 80 degrees, but that's not your A. The A is on the opposite side. I will repeat. A makes an angle of 40 degrees counterclockwise from A. From the X. Okay, from X. So, from X dito, counterclockwise ka ng 80 degrees. So, pag ganito ka. Then, that's not the A, but on the opposite side. That locates your A. Okay ba? Now, sir, question. Ako na lang magtanong kasi hindi naman kayo nagtatanong. Kung pwede kayo makatanong pa dito live. Anyway, sir, dapat pa palagi naming i-measure yung plane from the X? Pwede ba from the Y? Do you have that in mind? Or wala kayo naintindihan? Actually, you can measure it from the Y. Atinan nyo ha. If we measure it from the Y, how much would that angle be? That will be 50. So, okay. A makes an angle of 50 degrees clockwise from Y. Clockwise from Y. So, saan yung Y natin? Ito. So, you measure an angle of 100 degrees. Double that angle 50. 100 degrees clockwise. So, 100. 100. Dito ka rin mag-end kasi 180 man yung buo. Correct? So, 100. Mag-end ka dito. Then, move. There. You will get the same point. So, kahit saan ka mag-measure, you will end up at the same point. Gets nyo? Okay, so we can solve the stresses at that. So ito yung ating sigma A. So how much is that? Okay, so we have here the radius. The radius is 10, di ba? And this angle here is 80 degrees. The radius is 10. So your sigma A will be 30 up to here plus r cosine of 80 degrees. Di ba? Ito naman yung ating tau. So sigma A is 80. 30 plus r, 10 cosine 80 degrees. So that will give you 31.736 MPa. And the shearing stress is 10 r sine 80 degrees or 9.85 MPa. Naintindihan nyo? Okay, so ito yung stress normal to the weld. Ito naman yung stress parallel to the weld. Wala lang choices. Okay, I hope you got it. Ito yung gamit talaga ng Mhor Circle. Okay? Diba? So how will you design the thickness of that weld? So you have to know the stress first. Okay, now, last part. Let me show you. Diba in GEOTEC, soil mechanics, meron tayong triaxial test. Diba? Yung iba, marunong nun. No? Pero hindi talaga yung marunong. Na-memorize niya lang yun. No? Tingnan natin. Okay, paano ba yun nagawa? Okay, in view of this discussion natin ngayon, I will show you. Triaxial test. Diba ito yung triaxial test? How does it work? And what's the advantage of triaxial test? I've explained to you kanina the XYZ planes. No? Okay, in triaxial test, we have here a soil element subject to a confining stress, sigma 3, and an axial stress, which is the sum of the confining and the plunger stress. Di ba? The confining and the plunger. Kasi i-applyan mo yan ng plunger stress. The confining is due to water surrounding that sample. Okay? Ayan. Now, if you plot this, these are all compressing. No? If you plot these points, okay? Okay, plot natin into sigma negative and then tau. Kasi compressive yan lahat. Okay? Take note, your sigma 1 is bigger than sigma 3. The coordinate of x is, unahin natin yung y. The coordinate of y is sigma 1, 0. Kasi wala siyang shear. Wala shear dito. Ha? Meron siyang normal. Okay? So, sigma 1, 0. Ito, sigma 1. Wala siyang tau. Kaya, this is your y. The coordinate of x naman is sigma 3, 0. Alright, that will be somewhere here. Sigma 3, 0. This is your x. Alright? So, this is your Mhor circle. That is your Mhor circle. Ayos. Kuha nyo. The center is here. Na? Okay, the center will be the average of sigma 3 and sigma 1. Tama ba? Okay, now, di ba, when the soil fails, meron tayong plane of failure. Let's have that plane AA. The angle of that from the x-axis, tabihin natin theta. Okay, di ba alam nyo yung theta? Di ba theta is, kung meron tayong angle of friction, if you memorize the formula, theta is 45 degrees plus phi over 2. Phi is the angle of friction. Okay, if you still remember GEOTC, sige lang. Now, meaning your theta is always more than 45 degrees. So if you plot the plane of failure here in this Mhor circle, okay, how does it makes, what angle does it make with the x? Okay, plane AA makes an angle of theta counterclockwise from the x. So from the x, rotate ka ng counterclockwise, double of that theta. And take note that theta is more than 45 degrees. So doblehin mo yan, that will be more than 90 degrees. So ganito to. Ayan. Okay? But that is not your plane AA. Your plane AA is here. That, okay, this is 2 theta. This is your plane AA. That is your point A. Alright? The coordinate of that defines the normal and shearing stress on that plane. Diba? So 2 theta din yan. This is the normal stress at the plane of failure, and this is the shearing stress at the plane of failure. Remember that? Ha? I know, medyo nalilito kayo kasi iba yung nakikita niyo sa GEOTC. I will explain that to you. Manood lang kayo. Huwag kayong bumitiw. Okay. And then if you remember, if this soil is cohesionless, the tangent to the Mhor circle at the plane of failure ay dadaan dito sa ating origin. Ganon yan. And this angle here is the angle of that tangent to the horizontal, to the sigma axis, is the angle of friction. That's it. Okay? But this is not what you see in GEOTC. What you see is this. Panoorin nyo. What you see is that. We don't do that in GEOTC. We don't do this drawing in GEOTC. Ito yung ginagawa natin. Lahat. Panoorin nyo. Sayang yung animation ko. Yan. Yan yung nakikita niyo sa GEOTC. Sigma 3, sigma 1, ganon. Yan yun. Yan. Explanation ko. I'm just explaining. Wala akong value. No? I'm just explaining this to those who remember this one. At least this will reinforce your knowledge na talagang i-move mo yung point on the opposite side. This will further reinforce your knowledge or your yung paniniwala mo doon sa Mhor Circle. Alright? So, ano ba yan? Okay? By the way, what makes triaxial stress unique? Kasi, di ba, meron tayong z-axis x, y. Meron z. No? Sa z-axis kasi, the stress is the same as sigma 3. Pareho na sila na stress. Kasi all around yan, all around confining pressure. So that is why if you plot the z in this circle here, the z will also be, the stress at z is sigma 3. So the z is also located here. Kaya sa triaxial test, unlike kanina, kung pinakita ko yung tatlong circle kanina sa cylinder, sa triaxial test, isa lang talaga yung circle mo. Kaya that's the best test done sa soil. Triaxial. Isa lang yung circle mo. Isa lang yung shear mo. Unlike doon sa cylinder kanina, tatlo yung shear natin. Okay, dito isa lang talaga yung shear mo. Yun naman yung target mo, the shear strength of soil. That's the purpose of that test. to get the shear strength of soil. Okay, so I hope you learned a lot from this free video. I hope walang magbabas dito. Libre naman to, ulit-ulitin ko. Pero of course, sa atin to, para ano lang, makatulong din tayo. Ha? Makatulong tayo doon sa mga na-lockdown, tsaka yung walang, ano, yung nagtatrabaho. Yung mga nagtatrabaho, lalo na yung nagtatrabaho sa abroad, no? Walang references, or hindi pa kapag-review din, ano, this is for you. Okay? So again, so please don't forget to subscribe to our channel and comment naman, like naman paminsan-minsan. Comment para ganahan tayong maggawa ng maraming videos, ha. Kahit bola-bola lang, okay na yan, basta masayahan kami, ha. Okay? So thank you so much for watching.